Thank you. Thank you everybody for your attendance today, and it's good to have a bit of extra time. So yeah, Wabtec's been a provider, I guess, the last 20 years in proximity detection and collision avoidance technology. And what I want to share today is just some insights in terms of what the industry has been doing collectively in this space, and just some of the key learnings and insights that we've learnt over the last 20 years in terms of how to successfully integrate technology solutions into the existing mine site controls. And so yeah, this is vendor agnostic. This can apply to any OT or technology solution that you implement, particularly in the surface mining space. So some of the topics we're going to cover today is the industry challenge in terms of managing vehicle interaction risk and the industry approach. Looking at some of the industry resources that are available in this space, that are available to anybody in the industry, and the importance that technology solutions in this space are aligned to what the industry is doing. Just a bit of an overview on the different sensing technologies used in this area, with some of their limitations and advantages. Some of the capability of an intelligent rules engine to make decisions on when to generate proximity alerts to an operator. Looking at the importance of health monitoring and the reporting system. Looking at the user interface design that needs to have human factors engineering as part of the core design, and some of the key insights and learnings in terms of recommended implementation strategy, the importance of change management, including training programs, some of the recommendations for maintenance strategies, some of the new technologies we're seeing in this space, and some of the opportunities to add more value to your investment in a PDS system through systems integration. So from an industry perspective, we all know mining companies aspire to zero harm. Everybody home safe every day to their family and their loved ones. But unfortunately, we're still seeing some 30-40% of industry deaths are directly attributed to the failures of vehicle interaction controls, as reported by IMARC. And as a technology provider, I'm here today to tell you that technology solutions should never be viewed as a silver bullet solution to effective vehicle interaction controls. They do have a role to play when integrated with other mine site controls. So from an industry perspective, there is now a proven methodology that's been developed primarily through IMARC over the last 10 years, working with all the mining houses, the technology providers, the machinery OEMs and ICMM in developing a framework for managing vehicle interaction controls. And this isn't theory, it's been put into practice, it's been a proven methodology that has resulted in vehicle interaction control improvements. And the key is around not understanding the problem from an operator's perspective on vehicle interaction risk, not just chasing the symptoms with a technology solution. You need to look at how effective are your current mine site controls, and do they address the failure modes? And then using those failure modes to identify options to address the ineffectiveness. And it's a complex interrelation between people, process, the operating environment, production requirements, equipment design, and technology that needs to be operationally integrated with your current controls. And the key focus in the industry is on implementing capable solutions that deliver better vehicle interaction controlling performance. That 9-layer model on the right-hand side, well known in the industry, developed by IMARC. Those level 1 to 7 controls are to do with the mine site design, their operational procedures, that's the hierarchy. And then at levels 8 and 9, where technology can be provided as reactive controls to further mitigate vehicle interaction risk. At level 8, with advisory controls, where the technology should alert the operator regarding the specific threat and the specific intervening action required by the operator to prevent a collision. And finally, level 9 intervention controls, that last line of defence if required. Again, further industry resources, there's a very comprehensive body of knowledge. If you just Google IMARC, they've just done a full refresh on their website, comprehensive body of knowledge with a whole project guideline on how to implement a successful vehicle interaction control improvement program with full project management, guidelines, work breakdown structures, work packages, toolkits. For technology providers like Wabtec, we now have detailed functional technical performance requirements that allow us to develop effective solutions that address the problem with vehicle interaction controls. And also there was an ISO standard developed for level 9 intervention control that was an IMARC initiative. Further in the area of the body of material, one of the key documents is Performance Requirement 5A for vehicle interaction controls. Level 7 awareness, I've just highlighted some of the requirements there. The ability to provide enhanced situational awareness, alerting the operator to a potential abnormal situation, providing context to the operator regarding where is it, what is it, how far away it is, its heading, how fast it's going. Then escalating to level 8 advisory controls, where the system should determine an imminent threat of collision and provide a specific instruction to the operator to intervene. So this is talking about only alerting the operator when there's a potential hazardous interaction, not systems that beep and buzz all day as vehicles safely interact with each other, passing on safe roads on curved roads. This is all about highlighting the threat with voice-based alerting that gives the instruction to the operator on where the threat's coming from and the intervening action. Again, some of the material provided by IMARC, the top 24 vehicle interaction scenarios covering vehicle to person, vehicle to vehicle, vehicle to infrastructure, vehicle to environment interactions that can be used as part of those baseline assessments. On the right hand side, some detailed functional performance storyboards that have been developed that provide animations for technology designers on how to develop technology solutions that address these high-risk interactions, whether it's tailgating, whether it's a wet road, alerting operators of vehicles you're approaching a wet road that's potentially a loss of control scenario, alerting operators that the T intersection's occupied by a haul truck if you're an approaching light vehicle, those very close interactions like loading and dumping in terms of when the system should alarm, and a variety of other scenarios. So very detailed functional technical performance requirements from the mining industry to allow technology providers to develop effective solutions. In terms of sensing technology, sensing is critical. It's the whole front-end sensing of these systems that drives an intelligence system to determine when to generate those escalating alarms with the imminent threat of collision. There's a variety of sensing technologies used in this space. Mining 3 have developed a toolkit that was funded through an ACARP project that looks at all the common technologies used in this area, whether it's GNSS, whether it's ultra-wideband, whether it's LiDAR, radar, low-frequency magnetics, AI smart cameras. There's a great industry toolkit that goes through the advantages and limitations of the different technologies. GNSS sensing, again, commonly used in most of these surface mining systems because of the long distance, high speed capability. Obviously limitations on visibility to the satellites in the sky, operating in workshops, in a deep pit against a high wall. Do you need to augment that with other sensing technologies? In terms of the static heading accuracy, a single GNSS antenna system will not give you accurate heading when you're stationary. The vehicle needs to move at a minimum speed and distance. That's an inherent risk in that solution. And again, it's multi-constellation capability, the refresh rate, positional accuracy and heading accuracy. A lot of considerations in terms of the sensing capability. The rules engine, that digital brain that automates the decision based on the sensing information on when to generate a voice-based alert when there's a potential interaction threat. These systems need to be configurable in terms of the detection zones, the beam shapes, including curved scenarios. It needs to have good precision, high accuracy sensing, accurate and fast heading. The system needs to be dynamic, those interactive beams that are based on the speed of the vehicle, the braking performance of the vehicle, bringing in road gradient if that's available, and the payload of the machine to use the physics and dynamics of the vehicle to optimise these detection zones, to minimise nuisance alarms. They need to be interactive, using the other vehicle's operating state, the speed difference, the location and the heading, relative to the local vehicle. They need to be intelligent. They're conducting predictive path analysis, looking into the future of collision paths of vehicles, the time to collision, and starting to generate those escalating alerts. And finally, that instructional output, playing that audio voice message, conveying the specific threat to the operator and the intervening action. In terms of health monitoring, real-time health monitoring and reporting of faults to the operator, to a reporting system, also to maintenance personnel, is again best practice. Critical for maximising system availability and driving the site maintenance program. The self-checking needs to be standalone, not dependent on communication with other vehicles fitted with PDS. Should generate system health reports, from a fleet system health dashboard down to machine-specific faults, ability to SMS or email system health alerts to maintenance personnel, and where supported, the ability to link the PDS health to a FMS dispatch exception screen, so everything is in a single reporting location. The reporting system, generating event reports for analysis and actionable insights for informed decision making and continuous safety improvement. With vehicle interaction hotspots, the ability to conduct multiple journey replays for incident analysis. Should have rich geofence capability for scenario management across different vehicle types. Live position information based on mine site network connectivity. Reporting on demand or schedule. Fleet configuration management through over-the-air updates. And finally, system health reports. In terms of the user interface, it needs to be designed to industry best practice human factors to ensure that the in-vehicle operator, who's the end user, it's their office environment, that they receive the correct information with the correct context, they can quickly process and respond to those voice-based alerts of imminent threat of collision and the expected intervention to avoid a collision. And that maximises operator acceptance because you're solving vehicle interaction risk from an operator's perspective. And again, there's some great industry material available on the IMARC website in the human-centred design space. In terms of recommended implementation strategies, we've been in this space for 20 years. We've learned the good, bad and the ugly over time. So foundational key stakeholder engagement, absolutely critical to success, not only for PDS deployment, any other technology, OT deployment on a mine site. The Vehicle Interaction Control Improvement Program should be treated as a project, aligned to the IMARC work breakdown structure, need to get dedicated project manager, project sponsor. You need to aim for zero nuisance alarms as best as possible to prevent operator complacency due to over-alarming. And the key focus needs to be on those operators' zero harm vehicle interactions, the ones that have the high consequence of fatality or injury to the operator. The ability to tailor the alarm logic to those unique operational requirements. Conduct scoping exercises to develop the optimal machine installation standards. In terms of best practices, you need to work with the mine site IT department, look at mine site network coverage and capacity before installation, because you're going to have packets of information going from the fleet fitted with PDS back into a reporting system using the mine network. We recommend set up the reporting system with machine connectivity before the first machine installation. So you start collecting that rich set of data before you start rolling out the fleet. Run the system in silent mode. So the user interface is switched off in the vehicles before you go live. That allows you to establish a baseline before you've implemented PDS. Gives you the ability to optimise the rules and the intelligence behind the scenes if required. Need to implement a strong system for managing portable light vehicle systems for that short-term deployment. And controlled site access, particularly in the open pit area, to prevent vehicles that aren't fitted with PDS from entering those active mining areas. And that might be simply a boom gate that's triggered by a vehicle fitted with a working PDS. Change management, probably the most important aspect that either make or breaks the successful adoption and integration of technology solutions. You need to integrate PDS operation and support into existing systems and procedures to align with the cultural changes that it introduces. Stakeholder employee communications before, during and after the implementation program. Operator and maintenance training needs to be considered. Integration to existing safety training and reporting systems. Integrate into site procedures and develop new procedures related to the introduction of PDS. Your vehicle mine readiness requirements need to be updated as part of your pre-start checks. Need to look at spare parts and inventory management. Need to look at resource load planning for operations and engineering support. You might need additional resources to maintain and support your PDS implementation. Change management in terms of configuration change process needs to be defined. And importantly, define those KPIs to validate success. Track the change adoption and safety culture and ensure that the overall objectives are actually met. In terms of training programs, operator training, need to explain to the operators what the system does in terms of the user experience in the heavy vehicles, the light vehicles, and more importantly, what the system doesn't do. If you can use animations or simulations, we've found that's a very effective training platform. Obviously, pre-start inspections need to include checking that the PDS is working. You might have an operator in-cab quick reference guide and site procedures when there's a failure in the system. Needs to be training for installers in terms of installation, testing and commissioning. Need to look at maintenance training, health report analysis, troubleshooting, diagnostics, planned maintenance, unplanned maintenance and repairs. And finally, the reporting system, training the end users in how to generate those event reports, how to analyse the data and extract those actionable insights in terms of improving the safety of operations, how to set up new geofences, maintain existing geofences, how to run those journey replays for those high potential interactions. In terms of maintenance strategy, it's critical to design and maintain the system to a high standard to generate trust in the technology. And real-time health monitoring and fault reporting to relevant personnel and systems are crucial to maximise the uptime and guiding the maintenance program. In terms of the planned maintenance strategy, we've found that conducting system design and component FMEAs, generating those that feed into an operational FMEA that drives the maintenance strategy for this technology solution. You need to look at scheduled planned maintenance tasks and inspections to be developed and loaded into the site maintenance planning program. In terms of unplanned maintenance strategy, assess how the loss of critical functionality affects the user. Identify what additional controls you might need to implement, and those controls developed into trigger action response plans. From a technology provider, they need to provide essential maintenance support as well, whether it's remote technical support, training to assist the trainer programs, maybe training in alarm analysis, configuration adjustments, system health audits, and software, firmware, hardware configuration support. New technologies, we're seeing a lot of new technologies in this space in surface mining for PDS and other applications. An area of great growth at the moment is the use of AI smart cameras or machine vision for remote object detection and classification to detect people, vehicles, infrastructure, berms, edges and voids and personnel where you don't need to tag those assets. It's smart machine vision with edge processing on the heavy equipment that's creating that risk. Even the technology can be used for fatigue and alertness monitoring. It can provide IVMS capability for driver behaviour monitoring, whether you're distracted, whether you're driving unsafely with harsh braking, cornering, acceleration, whether you're wearing your seatbelt, whether you're using your mobile phone, whether you're smoking. So a lot of use cases are possible on a common platform using AI smart cameras. And this is an exciting space to be in and a lot of use cases in this space. LiDAR with the 3D point cloud generation, again for PDS remote object detection. It's used widely in autonomous haulage systems, road condition monitoring, Similarly, radar used in AHS and some PDS, but some challenges there managing nuisance alarms. When SBAS goes live by 2028, does your GNS system, is it SBAS ready? As soon as it has the ability to receive those signals and improve the accuracy of your current PDS deployment. The V2X or Vehicle to Everything Communication Standard that potentially provides great interoperability between OEMs and third-party PDS solutions. We're seeing good adoption in the automotive industry, some OEM offerings, we're seeing it emerging in some of the underground PDS, but I believe that's a great opportunity for the surface space, particularly around AHS and PDS interoperability. Video, LiDAR, GNSS data from fixed and moving assets, capture interaction, road user and environmental information, processed by edge computing along with AI and advanced algorithms, can provide vehicle interaction risk insights and operational improvements. Sometimes an investment in PDS can be seen as a grudge purchase, particularly countries like South Africa where it's legislated, but there's many opportunities to leverage your PDS hardware, your sensors and your data to add greater value in that investment. You can use the PDS to assess the effectiveness of your current EMIRC level 1 to 7 controls in terms of operator compliance, haul road design, your traffic management plan. You can use it as an IVMS capability, maybe an electronic pre-start inspection checklist where you don't have that with your FMS system. Opportunities to integrate hardware to avoid duplication, whether it's GNSS antennas and masks. Many machines you see, it's like a GNSS antenna farm. All these disparate systems with their separate antennas, there's opportunities to integrate those respective technologies. Again, using APIs, sharing data between PDS and say an FMS dispatch exception screen for reporting, for capturing the operator ID from the FMS database, adding it to the PDS reporting system. Real-time health monitoring and productivity monitoring using the PDS hardware for asset performance management. So you may not have FMS on your ancillary fleet, but again, PDS may have that capability. The ability to integrate with fatigue monitoring systems, taking the fatigue state, linking that to your PDS alarm logic rules. As an operator gets fatigued, their reaction time is going to be impaired. Maybe your detection beams need to look out further to provide that early advanced warning. The ability to integrate with other in-vehicle telematics systems and reporting system APIs for data sharing with other mining systems. Many opportunities to improve the value of a PDS investment through systems integration. Finally, IMARC ICMM now offer great resources for proven vehicle interaction control improvement solutions, emphasising that technology alone should never be viewed as a silver bullet solution. Capable solutions in this space integrate people, the process, the environment, production, equipment design, and technology that needs to be operationally integrated. The industry now has clear user requirements and standards that can guide the development of effective PDS solutions by technology providers. A PDS's ability to distinguish between safe and unsafe interactions depends on the sensor performance and the rules engine intelligence. You need to look at real-time health monitoring and fault reporting to boost the uptime and to drive the maintenance program. Capable PDS delivers rich reporting and analytics for better safety decisions and continuous improvement. The user interface should follow human factors of best practice engineering. Integrating PDS operation and support needs a strong change management program with key stakeholder engagement. Quality training is required for users, installers, maintainers, reporting system users. You need robust maintenance strategies with vendor support to ensure high standards and user trust in the technology. And the new sensing technologies will improve the overall capability of solutions with data providing greater insights into vehicle interaction risk and operations in order to prevent collisions, improve productivity and efficiency of operations. Consider those opportunities for value-added systems integration, leveraging your PDS hardware, sensors and data analytics. And finally, operators are still the primary means of control. PDS isn't a single silver bullet solution. Thank you for your time. The only marketing slide is stop by our stand C9. Come and experience our new Generation 3 proximity detection system, a full immersive simulator. You can drive a haul truck, interact with mining fleet, and we've got some smart AI camera demonstrations at stand C9. Thank you.